Well, welcome everyone. We are going to be covering Chapter 2. I am going to get started with a resource that is actually not the book. So let me go ahead and share my screen. One of the things that's talked about in Chapter 2 is this idea of domain-driven design. There are entire books on domain-driven design. Like everyone else, who reads anymore now that we have generative AI?
Yeah.
So just to get us kind of thinking, if you're not familiar with domain-driven design, it is referenced in the book, and there's kind of an assumption of knowledge. So I kind of liked the way Bard summarized it for me here. So there's 5 major points, and we'll be referring to in this chapter. So ubiquitous language, and then I've shown an example here, like a shopping website product might mean something different to a software developer than a marketing manager. So you want to make sure you're talking about the same thing. Bounded context is subdomain. So shopping website might have a bounded context for products, a bounded context for customers. Each bounded context has its own vocabulary. Oftentimes this breaks down, but not always, by your organization too. Like the marketing speak might be different from the, developer speak. Aggregate root is an object that represents a collection of related objects. So product aggregate root might contain objects for the product itself, reviews, and images. Value objects is a fancy way of saying values, such as a price or a quantity, and they should be immutable. Because again, remember, we're working in the analytics realm, so we don't change values, we just add new ones with timestamps. Repositories are objects that provide access to a data store, so a shopping website. There's lots of books on domain-driven design. It's been around for a long time. The sort of new application in Chapter 2 and throughout the book is applying DDD to this new idea of data mesh. We've been talking about this idea of decentralization for scalability.
Mm-hmm.
And this is all going to be about setting up, what does that mean? How do you break it apart, basically? And it starts by talking about your organization, so your organizational units. And then it again refers to product ownership and data ownership. But I find these constructs abstract. So she is starting to talk about her use case of her music streaming site, but I keep overlaying my use case. And so that isn't necessarily helpful. Maybe that's my problem, which is genomics. Here she talks about domain-driven design, and I actually found the generative AI summary to be a little bit more useful than what she had here. So that's why I started with it. The one point that I wanted to call out is the microservices architecture. So another way that data mesh has been called is microservices for analytics. So both data and computation broken into parts for analytics. So then she starts to talk about applying this, and she talks about this context of sending a bounded context. And again, I'm deliberately getting up to the drawing because these are a lot of words, and I'm kind of a visual gal. So I think that this is a great starting point, but it's tricky to think about any of the domains that I've been working in and think about how I would break them apart like this. And so one of the things that I found when I was thinking about how I would actually do this with a customer, again, I'll just bring up this reference, is I mentioned this last week, but very specifically in this datamesharchitecture.com site, which is associated with the DataMesh book and the people that are in her new company. They have some open source tools. And one of the tools that I found very useful in starting to think about how I would actually apply this or make my own diagram, as I just showed you, is this data product canvas. Now, it really goes beyond just breaking things apart, because it starts to talk about some of the other concepts in downstream in the book. I found it to be really, really useful. So I'm actually just going to pause here because I kind of started off quick and see what other discussion we might want to have about basically getting to the drawing. And let me just bring that back up. Does anybody else have any thoughts about this?
Yeah, just a little bit, an observation from working with the data zones and AWS and sort of seeing a little bit of the struggle. I was initially surprised that it seems like DataZone is going to rely on the AWS organization structure, which for everybody, at one point, AWS's approach was one big account, everybody works in their own little VLANs and stuff. It's now changed to say, oh yeah, almost every application should have an account. And now that, and so how do you govern that? Well, now you've got this overlay of organization. And as I started to work with the data zones, it started to line up with this idea of, yeah, each one of these circles I start to think of as like an account, and they've got things they do in their account. And then the data zone is, it looks like it's going to lay on top of that to say, all right, abstractly, what do you want to share? So this started, I mean, we pulled this up as these are a way of thinking about data domains. In effect, they're all little business units within the organization. But yeah, I'll show you when I do the data zone, you see that overlay happening as well. So it all still comes down to what are the business units trying to do in their little niche.
Yeah, for sure.
I have something. I'm just thinking. I don't know where would it come to. When we read this, just up there, she's just trying to tell us scale out, then decentralizing, which is implying to the distributed manner. So when this whole structure comes in the picture, do we still count it as a scalable structure? Would it be?
Well, I think that's the idea, to break things apart so they can scale. She hasn't really talked about how it will scale, but she's just said, so it can scale.
Can, okay. So yeah. If we see the scalability here, then it is breaking down to the smaller portions, smaller domains then the scalability is only implied towards the smaller domains, not the whole as a whole.
Well, I think by association, breaking, let's call it a data lake, into smaller structures. I think that's one of her central arguments, is that it allows for more usable, manageable scalability.
Yeah, there's an interesting other thing, sort of in terms of the scale and the back and forth flow. So as she's defined each of these within Duff, it's very clear what each of these do, right? But let's associate this with an enterprise where suddenly listener sessions becomes 4 unique little pieces, right? And I presume that, although it's not, we haven't covered it yet, but there would be a way to break up listener sessions into those 4 groups if they were, their volume and value proposition was so high that it invited specialization within what they start out with here.
Yeah, makes sense. Right.
Yeah, I think so. So going, she's did her typical style like she did in chapter 1, where she has an introductory diagram and then she layers more information in the next diagram, which I actually really like that approach. So she introduces the concepts that I think are really key to this chapter, the 3 archetypes of domain-oriented data for data mesh: source-aligned, aggregate, and consumer-aligned. Source-aligned, called native, and then later in the chapter she calls raw. That's pretty easy for me to understand, like just the data as it comes in that's uncurated. Aggregate domain data makes sense to me too, because that's your sort of classic reports. Where I think I have more to understand is around the consumer aligned, the fit for purpose. So then she starts to overlay this onto her diagram, which again, I like. Diagram 2 resonates more with me, to your point about, the listener sessions, for example. If it's custom aggregates, well, then those are some kind of either intermediate aggregates for downstream reports or some reports, basically. So when I would think about that, I would think about, okay, is that one huge report? Are there 5 reports? Are there, who's going to use this,
Yeah, it's interesting. As I think about that, as you're talking about aggregate, as I'm looking at it, would seem to imply, what is your focus on aggregate? It's probably going to be speed and volume, right? You're gonna, because you're not doing much with the data. So why do you exist? You exist to be able to get it out really fast. Or because if it's just aggregate, all right, yeah, maybe you're shaping some things, but in the other ones, it's very clear you're doing things with that data to make it valuable in some way.
Well, it's kind of hard for me with my, bazillion years of data warehouse experience to unlearn, because there's a part of me that looks at this and goes, source aligned, okay, that's extract. Aggregate is transform and load. And, and consumer aligned is, you put the results in a, Power BI or something.
Yeah.
Right?
Yeah, I would say the same thing. The consumer aligned is just a filtered version of your aggregate.
Yeah.
So if I'm saying I want consumer aligned recommendations, well, I want them recommending based off parameters, right? I've got a user who likes, action movies. I've got a user who likes romantic. Well, where do I get that source data from? I don't know how to get it from the source aligned. That's a mess. So you have some great team create that aggregate in the middle, and then all I'm doing is filtering that based off my parameters. Yeah, like a Power BI report. I would have a report that is consumable, easy to use, but yet can be filtered depending on the user who's looking at it. So, yeah, I agree. It's interesting. I do like the domain bubbles. The first graph actually spoke a little more to me, only because you mentioned the data swamp, you mentioned the bucket sprawl. And what I see, at least in our organization, is so we have employee data, we have student data, we've got fiscal data, we've got all payroll, all kinds of things, and everyone has a copy of the same record all over the place.
Yeah.
Right? But it's tweaked just slightly for that department.
Yeah.
So where I started seeing this is, rather than HR putting out their data set for everyone to use, and fiscal puts out their data set, and then benefits puts out whatever. Well, what if HR put out their data set of just their product is the employee, right? And that's clean and nice. And then fiscal data is just fiscal, my paycheck, hours, whatever. But it's mapped to the HR data. It's not fiscal's data that has HR built. I don't know. I see this as a way of saying, let's calm down, everybody. Don't throw everything to the swamp and just assume someone's going to know how to tease it out. No, if I want concrete real-time HR employee data and concrete real-time fiscal data and put them together, I should have really nice defined definitions to do that. And that's where I kind of like these hard boundaries.
Right.
I
hear you there, but then when you go here, like, okay, what is this thing? What is somebody's pulling from? Okay, I'm just not, again, maybe I just need to unlearn. I'm very, very aware when you have domain knowledge, it's hard to learn new things. And I might have too much domain knowledge here from all my background, because I really look at this and I go, okay, how is this different? So that's my sort of starting point. So then going on a little bit here, she talks about that you need to have not general purpose aggregates, but fit for purpose aggregates, which I understand that. I mean, I would, again, correlate that to my old world of people had views. I can remember making just so many. I used to joke that I would start with the person from the finance department who was paying my consultant check and start making their views first. And then everybody I would just write SQL views for. And then that's how I would make my, aggregates against the data warehouse. Everybody just gets their own views.
Yeah.
And then I do like that she, in this book, includes machine learning as just a first-class citizen, as if everybody in the world is using machine learning. In my world in genomics, everybody is, but I don't think that is the case with all
No.
data scenarios. Yeah, but I think that that's interesting, and that does reflect what my customers want. So here is probably the key point: transition to the domain ownership, to go, back to our previous discussion, rather than just copying it all over the place.
And before you let go of that, on that idea, the machine learning,
Mhm.
this could be that this is the data mesh becomes, or machine learning becomes a motivator for figuring out how to do data mesh, right? Because in a sense, if you've got a whole lot of aggregates, well, that's great, because now you can say, well, if only I had these and these and these, and I could pull them in from an aggregate, then yeah, who knows how far I could go with machine learning. But we were kind of promising that with data lake as well. But it, it gets to be a mess of, what exactly is the same problem with a silo. If there's so much in one place, it's hard to figure out what you've got. Whereas if your aggregates are sort of publishing, I've got this and I've got this and I've got this, they're almost all like those third-party data marts, where you're willing to pay a lot of money for that information because you know what you might be able to do with some of it. And if it doesn't work out, you just say, all right, I'm not going to use that one anymore.
Well, it is interesting with the massive amount of, they call it in human health, they call it now multi-omics data. And again, I have several scenarios because of the decreasing price of sequencing. I mean, I don't know if you guys are aware, but when you go for certain health treatments, you opt in, of course, but you will be sequenced like automatically now.
Oh, wow. No, didn't know.
Yeah, because the price is coming down so much, and the possibilities for improving patient care as there's better understanding of the effectiveness of treatments are just really driving this data collection. So what's happening in this realm is it's really extreme in terms of the amount of data in the data swamp. And this point about engineering features, as we've been talking about, I really see this all the time, because there's no lack of data. There's, even at cloud scale, there's a lack of not resources, but it's more cost. You just don't want to process everything because there won't be value in it. And again, I mean, there's some interesting things in the human genome. I mean, for example, for DNA, we're 99.5% alike, right? So for most cases, you don't want to process the whole genome. But it is interesting that in now starting to be some cases, the non-coding parts of the DNA, which is most of it, are being found to have a catalytic effect on some processes. And so there's kind of an A/B scenario where you are, training either subsets or you're training massive amounts. Again, genomics is just so interesting because of the truckloads and truckloads of data that are there. Anyway, so let me keep on going here. So push the ownership upstream.
Question here.
Yeah, go ahead.
Out of my curiosity. So when you talk about genomics, so you see almost like 99.9% of data is being processed for analytics, because they are still trying to figure out, they're still streaming many things in medical.
So there's a bunch of different things. So let's just talk about, how can I make it simple? So it's kind of started with the DNA. So that would be like inherited, because, DNA you inherit, RNA is what you make. That you then make the proteins in your body. So DNA research was first because the human genome was decoded first. And so there's lots and lots of work around, for example, trying to create more complete reference data sets, because even though that's been something that we were able to do for, 10, 20 years or something, there's still very incomplete reference data sets, because when you process any genomic data, you look at the particular subjects versus the reference. And if the reference subsets are incomplete, if, for example, they don't include non-white people, they don't include women, they don't include, blah, 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 then your results aren't going to be as accurate. And so like some of my clients, research institutes, are working in that area. They're trying to create these high quality stratified data sets, because anything biological, you can't just, spit in a tube and then it's 100% correct. There's, there's dirt, there's problems with the assays, there's all kinds of QC things when you have biological source data. So you have to do all these checks over and over and over and filter in ways that I have not really seen in any other vertical. So again, it's just really fun from a data practitioner point, because capabilities like cloud scale allow for improvements in process that are really necessary and not seen before. But anyway, I want to stay on topic here. So anyway, so data mesh challenges the assumption of that data upstream is less valuable or useful than data downstream. Basically, it says data can be consumable at source. And really, honestly, I was just sort of inadvertently giving an example with that junk DNA that I was talking about, because up until, I don't know, 3 years ago, that was considered not to be important. But the research institutes were still storing all of it. And now that the price of computation and sequencing is coming down, and there's been research around that data that was previously considered, junk, could be very significant. They're not going back and reanalyzing. So it's a pattern in genomics to keep everything forever, and because of medical advances. And it's interesting to see how that has really, well, what happened honestly is the COVID pandemic accelerated some of these processes, because some of these things that were only experimental were used in development of the various vaccines. And so these techniques are now being applied to, analysis techniques are being applied to domains like cancer. So it's a really fascinating time to work in this area, do you know?
Yeah, it would also seem to me on genomics too, like unlike any other kind of data, is there's no real expiration of the data.
No.
In other words, it changes so slowly over eons that, the more you get, the better, rather than, whereas in everything else, it's sort of like, if this data is more than 10 years old, I probably should throw it away, because, unless the law says I have to keep it, why spend money on it?
Yeah, my question actually, when I was asking Lynn about it, was pretty much towards the same thing. Then you are keeping it for the past 12, 20 years or whatever, and you are still processing it. So my question was that today we are dumping it in more precise way, more accurate and more minute data, which was not probably being captured earlier. And now today we are doing it. And in using that today's data, we are still processing the 20 years old data. So we are actually processing not just some part today, rather a pile long back. So processing is a lot more important now.
Yes, exactly.
Yeah.
It pretty much Norman was saying that it has no expiration. True.
Right. Well, and again, that's really goes directly to this point of the book: define multiple connected models, because in the case I'm giving, it changes over time. The case they're giving in the book is this fancy word polysemes, meaning, right? Shared concepts across different domains. So mapping one domain to another with global identifiers. And I put, this is my note here for the longitudinal patient record. This is something that's come in my lifetime, electronic medical records. And now the situation is longitudinal, which means like forever. Like starting to, again, going back to the when possible, and it's not always possible, but creating this historical patient record based on literally digitizing paper records if you're that old, right? To create a birth to end of life patient record. and then to multi-omics that with all the times that your data is sequenced. You know, if you have cancer or if you have some other, you know, condition that is epigenomic, in other words, results from you weren't born with it, basically you acquire it, combining those and then looking at the efficacy of treatment across stratifications is really, I mean, we're going towards personalized medicine is really what kind of the meta thing is here. But it's now, it's not a future thing. It's now, it's happening. So embrace, don't expect the most single source of truth. Again, I'm seeing that very much in genomics, which I think this is outside of genomics, this is more of a not yet there concept. Because,
Yeah.
You know, if I think of my business customers or my financial customers, I think that this is, it could be that it maybe is starting to be there in some, I think maybe like some of the social media companies have driven this. But I would think in small and medium businesses, they really aren't there yet. They're used to you know, their standard database, their reports, their financials. They don't have this kind of concept.
I think it's a matter of scale too, because small, medium businesses, you can afford to keep a centralized copy of everything. So everyone is pointing back to the main source. I read a really amazing article that honestly flipped my brain about a month ago. And he was basically making the case in global companies or huge companies, Walmart and all the other things. I think the cost of forcing everyone back to a single central data source for whatever it is no longer sustainable. And so what their idea was, let's say, you know, marketing comes out with a new campaign or new app or new something, and they need multiple addresses for the customer. And so they could dump millions and millions and millions of records from their current customer base when only 1% of the customers might use this new feature. And they said, actually, we don't care about old data. We don't even care about essential data. We just care about data that's accurate as of right now. And so they said, when a customer goes into the app, if you don't have their data, put the request out to go get it from the central source. You know, and if there's a delay there or something, but basically pull it in. But if it's not there, let the customer type it in. And to me, I was like, no, they're not allowed to. They already typed it in 3 years ago. How to go reference that one? And the guy was like saying, do you really believe the customer is going to type it in wrong? Maybe they've moved. Maybe they haven't gone into their profile and updated it. But his point was they probably are more cognizant of what the correct data is than a data set that was 3 years ago that's so constrained it may not be flexible to change. So let the customer type it in now, and then let some background process do some sort of data cleanup. And if you've got two addresses that don't match, ask the customer, you know, put a little notification or ask them an email or something, says, hey, we noticed you entered a new address that's not on file. Would you like to update your address? And the idea was that we're going to have these little pockets of seemingly the same data, but everyone owns their own copy of it. And you would never, ever do that in the old data days, and even the old data warehouse days or whatever, like you're saying. We would never do that here. It's impossible. But the idea that I build a feature that I allow the customer to update my data that could be wrong and not the central data, that to me was astounding, because we're getting back to these microservices, right?
Right.
Yeah.
Why constrain my feature and my small development crew? We put out a feature and we're getting customer response within days, weeks, or months of this new feature. Where in the old days, it was such a monolith and we were so dependent on each other, we couldn't release a new feature until 3 years of testing and QC later. The idea that I could have my own small pocket of data was just foreign to me, but I totally understood the concept in today's distributed microservices world. And I thought, you know,
Well,
and you could
go ahead.
There's another advantage that's implied there too, is you don't necessarily have to collapse the data down to this one's right, as long as you have a time sequence. You know, because then you can see the transition state of something over time if you need to see a trend you hadn't thought about. So yeah, if the customer gives you a latest one, you don't necessarily have to go in and update it. You just store it and try and make it more likely that if somebody does a query, they're getting the latest one And that could force you to do some centralization. But as you point out, yeah, maybe it exists out at the outlier area because the customer just gave it, and there's a longer sequence to get it added into the central, wherever that might be.
There's
Yeah,
an
so-
official consistency you have to work out. So I updated it in my feature, but the traditional app still shows the old. Yeah. But again, that goes back to fundamental things that we've been trying to solve for the last 5-10 years. How do you distribute data and keep eventual consistency? But sorry, Lynn, go ahead.
Yeah.
Oh, that's okay. So I think, again, the concept here is that data is more biological than mechanical, and it's time relevant. And I think that what's driving this is the volume of data. So again, I think the social media companies and domains like genomics are driving it forward. But yeah, if we get rid of strong consistency, then we get rid of relational databases. Now, I think there will always be a place. I always say relational databases are for money, because you need to have transactional consistency for money. At least I haven't seen anything evolve beyond that. So to run your business. But for the other information, that was the whole realm of NoSQL, right? So it could scale on the operational side. So bringing that to the analytics side is, I think, part of the new concept here. Kind of the concept of NoSQL, but on the analytics side. So you're right on in our discussion of eventual consistency in analytics, because that's new. That's not what people are used to. So.
Yeah, I teach a night class. I teach this scalable system design, and these are for all people trying to get into the big 5 companies. And I'm really only there because I work for one of them. So like, oh yeah, you can teach. Yeah, great. We'll pay you money. But I always tell them, I said, listen, if you're doing a scalable system design, be very, very careful and precise if you say you want to use SQL. Because because your interviewer is going to right away say, oh, wait a minute, is this someone who's not up to date on, what the data platforms are? So yeah, I forced them to say, tell me again why that this strong consistency is so valuable to you. Because even banking, if you can batch it up at the end of the night, it doesn't have to be exact all the way down to the center, just as long as you've got something at the outskirts that tallies up to what that user asked for.
So again, just to recap the chapter, so the really key takeaway here to me is this fuzzy class, and notice the word fuzzy classifications of domain data, source aligned, so the native analytical data created and shared by the teams who own the source operational, aggregates, the analytical data in the middle, they're owned by the producer or consumer, and the consumer aligned, designed. So again, before I turn over the demo thing to Norman, I just want to show just one little aspect of working with Google Cloud Dataplex, which is the discoverability. So this is in the product itself. Finding things, right, is one big part of this whole concept of Dataplex. Because if you can't find the product, it's not usable to you, right? And so this plane where you can search, and you can search with these different filters, to me is like a starting point. When I'm thinking about making data products, I'm thinking, okay, using this set of services, how would I want to set these circles up, if you will, so that people could find them? So what are the default filter areas? So, it just starts with starred, everything, and then it goes into the different types of services. So whether it's BigQuery or, buckets or what, BigQuery is the data warehouse. Then the data types, and there's, in my opinion, too many. I had to look up some of them to know what they were. But notice, this is kind of interesting on the data types. They do have machine learning models, which I thought was interesting. And then under the projects, this is the Google approach to how you group your set of services together. And then tags are the custom tags that you can like geotag or whatever. And then data sets are BigQuery data sets. So this would be like your data warehouse. And then you can say whether you want public data sets or not. And then when you pull these things together, you can see that it's going to show you the name, it's going to show you the description, the type, the system, the source, the project, and when it was modified. And again, I kind of peeling this like an onion. Like every time I look at it, I see something a little bit more. And when I'm thinking about designing, I would start with what capabilities are in my cloud platform. So I would start by saying, okay, this is the metadata that by default exists. You can add more because I want to make an environment for my consumers of data that they can just literally search by filters that are meaningful to them. And then once they find the data, they can then operate on the data. So they can understand more about it. They can look at the schema. They can figure out what they're going to do with it. In the case of BigQuery, which I don't have sitting up here, you can actually open it in BigQuery. Let's see if I can get BigQuery to come up here, which is, to me, the sort of ideal thing when you are working in this kind of area, that if you can just search in here, and then when you're ready to go, but obviously I don't know how to use the filter thing very well yet because I can't get it to, maybe, I think it's there we go. So here in BigQuery, this would be, my expectation that, okay, I found my data, now, oh, cool, I can just work on it in BigQuery because that brings the data and the computation together. That's my expectation, right? When I'm building my data product. I got my data, and now I'm going to do something with it. I could also explore with Data Studio, which is like a Power BI kind of thing, or I could scan with data loss protection. I think it's called protection. This would help me to understand if I had any sensitive data, or help me to understand if I was the data was properly protected. So this to me is very interesting. I see how this works with BigQuery. I don't see how this works yet with Data Lake, but I think that's because I haven't explored it enough. This to me is very interesting though, because this meets my users' needs. Like they have too many BigQuery data sets. They don't know how to work with them. They can't find them. They can't find the BigQuery data sets versus the files and buckets, what's where. So I can see that this search environment could provide value. And with that, I'm going to stop sharing and see if anybody has any. Oh, go ahead, Varsha.
I was just thinking of that the pan you were just showing with the BigQuery and the option for DLP. Does it really imply towards the encryption?
So it's actually awesome. What DLP does is it has some permission, but it scans either on demand or on a regular basis. So if somebody, it's like GitHub if you check in a secret.
Oh, okay.
It's like that, basically. You have to configure it, but it's fantastic because haven't we all run across that problem of this data that should not be in plain text or should not be available to somebody is available. It's secured incorrectly.
Got it.
Yep. Go ahead, Norman.
Thank you.
Oh, terrific. Okay, yeah. So have you all worked with the AWS Management Console? And I know you have a little. Yeah, okay. So, my first experience when I came into AWS a long time back, it was like, oh my God, I have to learn how to be a system admin all over again. I thought we were moving above that. So I'll tell you one interesting thing I found about DataZone, and I'll show you this. But there's a movement within AWS now to say this is not the right interface for a lot of people. So it's kind of the hot products in AWS right now. You've got Connect for call centers. Almost as soon as you set one up, it brings you to a portal that doesn't look like this. The challenge with this one is if you get in here, you could potentially destroy all sorts of things by mistake. right? So DataZone Connect does it. I was trying to think, what was the other one bumped into? Well, DataZone follows this model as well. And it makes sense here because this is the last way that you would probably want to communicate to business leaders. Here's how you can do things and share things to show them, a subset of the hundreds of things available. So now with that, I'm annoyed that I can't remember what the other one was. Oh, QuickSight, which is a visualization product. Again, once you subscribe to QuickSight through this management console, then every time you pick it, you immediately go out of the management console to a portal. So the other thing I have to sort of is a little bit of preamble in the way AWS has like I said, a particular business challenge around getting data mesh right and what they'll call DataZone, which is the way that data lakes were created. With this lake formation, automation, put it in raw. You've got these 3 buckets that you curate it, and then you aggregate it in a way that you can share and other people can use it. It was really hard to share data between the lakes. So start with that premise. Initially we said, oh, data silos and companies are bad. If you just throw all your data into a data lake and everybody can see it, that'll be good until you bump into regulation and they're like, oh, well, wait, we can't just share everything to everybody in the company, or particularly in public sector where you're delivering to particular constituencies. So the problem, aside from the market sort of rushing forward with data mesh, the be all end all right now, I think, is getting the governance layer right. And now there's another challenge with that approach as well, which is you've got a lot of what we might otherwise call legacy technology that you've got to figure out how to bring in under this new technology, because that's what you're trying to solve for, versus when we're looking at data mesh, it's your greenfield. Let's, we can do anything we want here because we're focused on a business problem. And I'll give you one more sort of intro that, as I alluded to before, Amazon 10 years ago, you get an account and then you create your little VLANs in that account and you'd organize your applications because everybody still had a kind of a data center mindset. Current today practice is no, give everything its own account, because then you've got nice security boundaries. So if someone's in one account and they do something bad happens, it doesn't impact everything, right? So now there's this proliferation of accounts, which presents another governance problem. That governance problem was solved with organizations. So you could sort of take all the sprawl of accounts that you had, put them in kind of a structure, organize security and guardrails on each of these groups. Your goal there was not to share so much as to protect and organize these things to a central structure. So DataZone arrives at a nice place where it's solving 2 problems really. The AWS, how it's sort of being talked about is, well, one, you need an organization because the security boundaries tend to align with organizations, but you want to be able to have a control over the top. So this is so with that preamble, I've set up my DataZone, and what you'll see. Am I in the wrong account? Because I'm expecting that I've got. Oh no, this is right. Yeah, sorry. It scared me because that looked like what I saw when I first got started. So as soon as I had to do a lot of pre-work on data zones. Like I started with an account from scratch, and I was like, oh, all right. Do I have to do organizations yet? And I figured out, oh no, I don't quite have to. Even though when you read through how it's being, the recommended way is to, hey, you're in here because you want to share lots of data, probably across lots of accounts. The organization is like the way of looking at how do you create some of those security boundaries? Because remember, the data producers are going to publish a catalog of things they want to share to consumers. There's some kind of an authentication layer going on, and it's potentially more restrictive what the data producer wants to share to the data consumer than all the data lake that sits underneath it. So what's attractive about this is it's a nice abstraction layer, and this is kind of what, let's see, let me get to data domains. Yeah, okay, I'm sorry, I'm still in Management Console, but I'm about to jump into my, this very Management Console. I've got, things I could pick from and dive deeper into. But let's look at the data portal now. And again, I'm getting really good at setting these things up really quickly because I made a couple of mistakes. But this is what that business layer presentation is supposed to be. Now I had to, if I go into the place so I've got these projects. It's almost like this is the Windows equivalent of a reboot. Whenever you're not sure about something, you say browse all projects, and it sort of takes you up to the higher level. And so now here I can see, well, what are the projects that are out there that I can pick from? And this all came right out of there's some documentation for DataZone, and there are like 9 steps to how you get started if you want to play with it, and it gives you a sample data set. It only operates right now on use heavily on Athena. You can apply it to Redshift, and because you've got the Athena glue in there, you can dump a whole lot of stuff in storage. And the Athena glue can create a catalog that you can use, but those are the only 2 things it supports right now of the many different ways of storing data. And in this case, the sales was the producer of data, the first one that I set up, and then in the same account, although it could have been in a different account, then I set up another project for marketing who wants to consume some of these things. So let's go look at what my producer has out there, and the view from that producer. So the first thing so I've got a list of let's see, this is my portal where when somebody says I want something, I'm going to wind up with a notification saying, oh, somebody wants to use the data set that you've got. But let's see, let's go dive into, well, let's look at what this so yeah, this is meant to be the and again, very preliminary stuff. It's only in preview. The approach generally, as you probably know with AWS, is get a minimally what we call now a lovable product instead of viable, and then as customers start to use it, figure out what you have to do next by the customer saying, it doesn't have this and this and this, so don't try and market strategy what your roadmap should be like. Put out something that's helps enough people that you start getting feedback on it. But you see, I've got my tool sets over here of a lot of the analytics right now. The way I had to set things up would all come back into using a query through Athena. And so now it starts to look like, now I'm going to bump into, I'm back at the Management Console, and this is the same way that we always sort of, we've gotten used to. How do I do searches on things that are in S3? That I've created this glue catalog that Athena then uses. So if I pick on, if I pick on this one, no, I didn't have a table.
While you're doing that, I'm just going to jump in because I just know what these guys don't know.
Okay.
So basically, this is functionally similar to BigQuery, and this is serverless data warehousing. So the idea is that you have CSV files, and there's other formats, but just text files in buckets, and then you define your schema, because there has to be a schema definition somewhere. And in Amazon, it's using a different service called Glue, and then the query engine here is Athena. The equivalent in Google is BigQuery. You set up a BigQuery data set, and that's basically a fancy bucket that has a schema on it. And then you have these query windows, and you get charged by the query. So this is modern data warehousing. You don't have, database servers or anything. You basically have pay by the query. And this is not new. This is something that's been out for a while, but a lot of small and medium businesses are still using traditional data warehouses. So I just wanted to fill that in because I don't think, given you guys' experience, that you were familiar with that.
Yeah, what I found that go ahead.
No, I think it's typically we need a schema to read the outcome. That's all. I mean, reading schema we need basically out of a lake, and we are providing the query and filtering the data and reading out the outcome. That's all.
Yeah, that's where I was going. Yeah, it's a schema on read, right?
Yeah,
you just throw a bunch of stuff out there, but you have some intermediary that's sort of building the catalog of what are all the things that are out there. So I'd say DataZone right now, like I said, heavily reliant on S3. Just throw everything out there. There's already a tool that can go and find things for you, and then what's fascinating to me about Athena, right, is you can do SQL queries on completely unstructured data. Because the glue finds things that have structure, and then Athena can look at the catalog, this one up here, and say, oh, I see something out there. It's not a database, but it's rows and columns, so I know what I can do with that. And that's sort of, so this technology, not really new at all, but in the DataZone, this is how, so it's not as rich in terms of search capabilities as the producer of my if I go back to browsing all my projects, as I've produced something that I want to put out there and make available to people, I get to define what I'm going to call it. I've got some ability to do some of the metadata changes to make it easier at this level for somebody to find what they're looking for, but in contrast, it's not nearly as rich. Surprise, surprise. Google's got a very imaginative way about how to do search, what people might anticipate, how deep you can go with it. This is fairly simple right now in terms of. Let's see. So I think I've got over here.
Can you click on the actions in the upper right?
Oh yeah, sure, yeah.
Oh yeah. So I can see what's there.
This is what I have published, right, that I'm going to describe. But yeah, my actions up here are,
okay.
The main thing I'm going to wind up doing a lot of is publishing data. And then when I'm a consumer coming in, I'm going to, let's see. So marketing, when they come in as a project, they're a looker, not a builder. But then they can. So where did they get their? Trying to remember now. Subscribe data. So they. So if I do all subscriptions, I only have this one thing to be subscribed to right now. So within DataZone, the marketing team would come in here. And I haven't, again, let's see, it's probably at my data catalog, all the things that.
Well, I noticed on the right side, they had subscriptions as a place, as one of your resources.
Yeah.
What that meant.
Oh, all right. I'll jump back there. Yeah.
I don't want to interrupt you, but.
No. So I just want to point out, data catalog is like that first level of what are all the things that you might want to subscribe to. And I don't have to be in any particular group. This is my domain. The only thing I've published so far is product sales data from the sales team, and they can name this so to make it searchable. But if we go back and pull up,
either screen would answer my question. So see on the right side, it says configured resources. You got your S3 bucket. That's, I'm assuming, your sources. You got your published DB, that may be what you're publishing, and then the subscription DB. Either way, so if I'm in the company and I subscribe,
correct,
to me, subscription sounds event-based. I'm going to be notified upon changes. Is that how it works, or does that simply give me access to read from it? The subscription database, it doesn't have to be a one-to-one, but if I'm in sales and I've got I'm publishing, here, well, let's click on it. It always, and I don't quite understand this, but everything I've done so far, you always wind up with this pairing.
here's the database of what's published, and here's the database of what's subscribed to. Presumably, although I haven't seen this, I might take my published, which is the universe of what I'm putting out there, and then create separate, smaller subsets to subscribe to. So you don't have to subscribe to everything in my database that I'm publishing, but it's up to me to define. This one, now that I remember this, in the subscription database, I have to point to what is the glue thing that created that database.
So that's really just a database of subscriptions.
Yeah. And the thing I'm not quite seeing here, I'll show you one other thing, and I'll share this, but for that class that I'm teaching, this is a list of, the back of a lot of the chapters. Well, we haven't gotten up to 7 and 9, but she's got these, summary, almost like a cheat sheet. So when we get up further, but what my student's going to do, because he has no choice, he's going to take this subset. We have a 2 or 3 hour long class this Monday, and he's read the book, right? Well, together over the time, and he's going to have to score the data zone to say, okay, from the data mesh point of view, how well do you think that thing is doing on each of these requirements? But if I were a consultant, this is like a gold mine, right? Because this is how I'm going to produce my gap analysis. If I go in and somebody says, I have a pain point, and I'm like, oh, that's great, because data mesh can solve your pain point. Let me do it at a maturity level of how you're doing it now. And, I can walk them through an eval like this. But as I say, I'm going to use it to say, how does a data zone match up? And again, minimum lovable product, it probably has some things and certainly not all of them, but I'll share this up on the GitHub site too.
Great. That would be really great.
It would be nice, yeah.
Well, thank you so much for doing all that work to do that demo. So interesting. So interesting. This is why we do it, right? So we are getting to time. So I think we have a meeting next week. And I'm wondering if anyone else would like to lead chapter 3.